it's the best we can go, but let's see. If the group is intimate enough, we can always do a quick round of intros. And anyway, you should just intro yourself in the chat. We'll go through it in a second. It's the best we can go, but let's see. If the group is intimate, sorry for that. That's YouTube Live. That is just in the background. In the chat. We'll go through it in a second. Sorry for that. That's Darren, can you please mute your YouTube channel in the background? Okay. Oh, some more people coming in.
Okay.
And yeah, if everybody just wants to introduce themselves, maybe just tell us kind of your name, location, and kind of what you're excited to talk about today. You can do so in the chat. That'd be great.
We'll be starting shortly. And this is, I know that you can't see the slide, but this is the right webinar. Anthony will be talking about what digital assets has been doing. And yeah, we'll be just starting shortly, waiting for people to join.
Hi, Jose, how are you? Todd, good to see you.
Likewise.
I'm really curious, actually, because looking at names, I'm wondering how many of you are from the US versus Europe, because we always thought that this hour is best for people from the US, but then I see some friends from Europe. So if you want to pop into the chat or speak up where you're, yeah.
Belfast, nice.
Thanks.
Okay. Okay, Karen, do you want to go through the housekeeping?
Yeah, okay, let's get started. Well, welcome everyone to an in-depth hour with digital assets. We have Anthony here with us today, and he's going to be going through a really engaging presentation. We have just a few housekeeping items that we're going to go through before we get started. The slide would change. As with many of you who are familiar in our community at Hyperledger, we follow an antitrust policy and have an antitrust policy notice that you can look at on our website, or you can take a look at the QR code on the screen that you're looking at right now. This session is being recorded. It will be available on our website on the webinar page. We are also live on YouTube, so you'll also see a recording on YouTube later on. And the slides that you find in this presentation will also be included in the description of the recordings. This in-depth hour is a very engaging opportunity. So Anthony's, of course, going to share something that he's prepared with us for you, but we absolutely hope and expect and welcome you to get involved. There's a couple ways you can do that. You can raise your hand via the emotion signals that you have in your Zoom menu bar. You can also come off mute. Or type into the chat any questions you have or comments you want to make. We'll be monitoring all of those and giving you that opportunity to jump in when you can. Ask any questions, don't be shy, and we're here to, this is a learning session. This is here for your your opportunity to learn something new about UTXO and account models. I'm sure you're here because you're interested in that. And so please take full advantage of this opportunity to be here with Anthony.
Absolutely.
We do have a regular series of these. So our next couple ones are, the next one is with Consensus on March 17th. And then we have the Valid Network presenting on March 31st. And these are also similar format, very engaging, here for you to learn and ask questions. So if you're interested in either one of those topics or companies, please sign up for those as well. And of course, there's many different ways you can get involved in Hyperledger. You can check out the community page, the resources page on our website, engage with us in the chat and our various projects and SIGs and special interests or working groups, our wiki, our mailing list, etc. I'm sure many of you are already participating in many of these. And I'll let Anthony get started.
Okay, awesome. So I could share my screen now?
Yeah.
Okay, great. Yep. So thank you very much, Karen, for the introduction. And thank you both to Karen and Marta for just giving me the opportunity to talk about all this. I'm really excited. I'm actually just going to bring the Q&A and chat box back up really quick, so don't mind me, just so I could see if anybody has any questions. But yeah, thank you very much. Today, if you haven't introduced yourself yet, you can go ahead and do that in the chat box, or if you want to unmute your mic, that's fine too. But we do have quite a lot to cover today. So yeah, today we're going to be talking about UTXOs and account models, the good, the bad, and the costly. That's out of my very clickbait title, but hopefully it got enough people to join so that we can kind of check it out. And there are definitely good positives, negatives, and costly mistakes in both these models, and we'll be talking about some of those a little later as well. But we're also going to be pointing, we're also going to be painting with very broad strokes. So in the first half of this, we're really going to focus on general designs themselves before we get into the nitty-gritty of what an actual UTXO or account model implementation looks like. Really, to describe even a single one of these would require much more time than an hour to really understand how the implementations work. Even in real life, there are a lot of very hybrid models or other things going on that don't perfectly fit in these boxes. So there's always an exception to everything. So really what I want to talk about is how these systems generally behave by default and with the least complexity in their designs as possible. Least complexity helps us not only understand what it is we're talking about and what we're looking at, but also the least complexity possible tends to have the least bugs or least issues or least things that you as somebody designing an application or using a UTXO or account-based network need to really worry about. So that's always good in general. And yeah, so my first question is basically to everybody in the audience, what are UTXOs and what are accounts? Can somebody maybe give me an example or a definition? You can feel free to unmute yourself or you can mention it in chat. And if
no idea, that's why I'm here.
Perfect. That's always good. Okay, so I'm sure some people.
I see that Santiago mentioned that it's unspent transaction balance, and Can says that the UTXO is like paper money bills.
Yeah, okay. Those are actually great examples. Yes, so Santiago is correct. UTXO stands for unspent transaction output, and a series of those outputs could represent anyone's balance on a ledger, or it could represent a variety of other things. Ken is also correct. In the real world, UTXOs are like paper money bills. And HT, yeah, that's a very interesting point. HT mentioned that UTXOs basically, within Bitcoin, a bunch of them make up your account, which kind of ties into the balance that Santiago mentioned. And that is right for the Bitcoin implementation itself. But when we're looking at these things, we're going to probably be looking at them more in isolation. And then on the other side, what I mean by accounts in this, since it might be a bit confusing, and I could totally see that, is an account is kind of like, and this kind of gives away one of my examples later, like a bank account where you may receive money and send money and so forth. And ultimately, though, all that money, all those transactions all represent just increasing or decreasing the value on your account balance, for example. Within the context of, blockchain and distributed ledgers, these things are a bit more complicated because they don't only hold just things about money, but things about all sorts of parts of the world. And so that's the general gist of them, where UTXOs are like a consistent ledger of debit and credits. This changed, this didn't, this changed here, this changed at this time, is a UTXO model. An account model is, this thing got updated, and there's less of a record and there's more of a tying of these things together. So they do vary a bit in that way. But now maybe we could come up with some examples. Given those definitions and what people already mentioned, we do have some examples like where Ken says that UTXOs are like paper money bills. And I had mentioned that accounts are like banks. So does anybody else have any other examples? And feel free to put them in the chat or to say them out loud.
We have one comment, one question. So HT said that an account has UTXO and Bitcoin picks the lowest one. And then Santiago asked, how is an account differentiated from a wallet to preclude a double spend?
Yeah, so what HT said is correct, as I touched on there. And for Santiago's question, how is an account differentiated from a wallet to preclude a double spend? So that's probably something we'll go into a little bit later, and it's actually really more about consensus rules than the designs of these systems themselves. So I'm actually looking at these systems as if they've already figured out how to manage consensus and eliminate double spends. And in real life, in Ethereum, for example, and this will be a note that comes up later, so it's a really good question, is the way you're able to preclude double spends on Ethereum are Ethereum does proof of work, which enforces transactions, transaction order essentially. And the other thing is that within account systems, you typically have something called a nonce that basically each and every one of those ties to can only be used once. And because of that, this little bit of information precludes somebody from like if I were to send Santiago a transaction on Ethereum, I wouldn't want him to send that same transaction again. And that's kind of how you prevent double spends in that way, if I'm understanding the question correctly. So yeah, perfect. So we've had some explanations of account models, and here's some of my ideas on real life models. And really all of these models are very ancient. We have on the UTXO side, the real life examples being cash and coin money. Coin money in particular being one of the earliest examples of what you could consider a UTXO. They are things that, you send them from one person to another. If you were to split one in half and give the two pieces to two different people, other than them coming together and figuring out that that was from the same half of the coin, that's pretty much it. There's no other tie between them. So if one of those halves got given to another person, that person would have no link between that half of the coin and another one, for example. And on the account side, we have banks, like has been mentioned, and we have credit cards, which do the same type of thing. They keep track of a list of debits, and then every month you settle up. And then we have very old examples when it comes to accounts. I would say in general, accounts and these types of transactions accounts probably predate UTXOs in real life usage. There's a lot of history behind it, so I won't go into that. But one interesting example are these Bull tokens that essentially are an account and also are somewhat of a UTXO. They're really interesting in that the outside of them demonstrates what is owed, and the inside of them is the identical of what has been received. And kind of that happens by, they basically press all these little bones that represent different things into the tokens, or these different stones, and then they seal the stones inside this ball that has those impressions on it. So when you want to go and redeem your debts, you can actually have somebody will break it open and see that nothing had been changed. It's really interesting because you can pick it up and take it around with you, and then go back later to whoever owed you something or whoever owed you and redeem them that way. And those are a whole bunch of different real life examples of UTXO and account models. So now, and I really haven't actually thought this question through much, so I would love it if people had some ideas, but for these models in the real world, kind of between UTXOs and accounts, what are some of the good things about them, and maybe what are some of the bad things about them? Like, what are the trade-offs from choosing these models?
Feel free to come off of mute if you like, or you can type in the chat or submit a question.
Yeah, Santiago actually has a really good point there. Data storage is definitely within blockchains themselves a consideration when you're going through between UTXOs and accounts. That we'll actually get into in a little bit, and that's basically an answer to another question that I have. But in the real world, like, what are the examples of having dollars or coins versus having, bank accounts or credit cards? And Fergal says concurrency. Can you be a bit more specific about concurrency?
I guess you gotta consider concurrency for UTXOs. You gotta wait for this chain to come back before you have an available balance. And similarly, then with
I'm sorry, Fergal, your volume's a little low. I couldn't hear that well.
sorry, can you hear me now?
It's
A little
still
bit.
a little quiet.
It's a little low. You can feel free to type in chat too if that makes it easier.
For UTXO, it would require a lot of aggregations.
Mm-hmm. Yeah, that's definitely a negative of UTXOs there, that they could require a lot of aggregations. You kind of have change to deal with also, like you just mentioned in the chat. And yeah, on the account side, one of the negatives is that you have to have a nonce and manage it. And we'll actually see that nonce has some other negatives too a little bit later in this. Alfred also has a really good point that privacy is, I'm assuming you're talking about UTXOs, privacy is a bit better in UTXOs. That's also something we're going to talk about, so that's really awesome. And yeah, Santiago also brings up that UTXOs, one of the advantages they have, and it kind of ties into what Fergal said, is that they're divisible. And so they have a really nice property where they get divided and split around, and accounts have a really nice property where you get basically a real-time update to an account, and you get to see the balance for the account without having to compute it out all yourself. In blockchains, obviously, in both of them, these are abstractions on top of how these things actually work under the hood. So in both, you actually do have to do all that computation. But when you're reasoning about these things actually as a user of them, then that's when these things come into play and are very interesting. And yeah, Andre also says that, you know, you get bigger control of funds with UTXOs, which is true. You get to pick which of your bills or coins you're actually spending. And yeah, Alfred also has a really great point there that, you know, smart contracts are, it's easier to reason about accounts when you're programming smart contracts than it is UTXOs. I will tell you I'm probably partial to UTXOs, and that might come through in some of the rest of this. But yeah, that is a good point, is that it actually does make reasoning quite a bit easier here. And yeah, so those are great. And now we're actually going to hop over to blockchains, and you know, we've actually kind of covered quite a lot of that. So or actually when we're thinking about the real life versions, the analog versions almost, but not exactly in all cases, they kind of translate to the blockchain digitized versions pretty well, in that they are at least 90% by whatever loose qualitative metric I'm using there, are very equivalent. And so I spent a while thinking about this, and you know, we've kind of gone over that. So let's go on to and on the technical side too. I think that people have really dived into that, in that, you know, these are the same types of things. So if you have any specific other ones you want to add about the technical side, you know, you can feel free and mention them in the chat or unmute yourself. But for example, you know, like Fergal said, there's a concurrency. That's really nice, because if you have two separate $20 bills and you spend them in different places, the different places you spent them, they don't need to worry about, for example, what the other $20 bill is doing. Whereas in an account, you actually do, and that's why you have intermediaries, for example, on a credit card, that are keeping track of this running balance, and they want to make sure that when one balance up, if you only had $20 in your account and you spent it, you're not going to try to do two transactions right next to each other, where you debit $20 both times and end up running under. You actually, for a debit card, that would be what you'd be doing. And then, yeah, like Santiago had said before, there's a data storage consideration. So on the UTXO side, and this isn't always true, but most of the time it's true, there is more data storage for each individual UTXO that's doing a very basic thing, as compared to an account where the transaction is also doing a very basic thing, such as changing a balance. Oftentimes in accounts, those are smaller for a variety of reasons, mostly because in UTXOs, you have to track the thing that you're debiting itself, and in accounts, you just kind of do the debit and make sure that when you're doing it, that it's allowed and it's not going to overdraw the account. And I'm also talking about these things in context of accounts, but they really apply to all sorts of applications that you can run on these things. And you can think of accounts really as changing state in an application, changing what data that application is storing. And Gaurav has a really great point here, is that on UTXOs, one good thing about them is that sharding is possible. So like I said before, if you have two different UTXOs and you spend one here and one in another place, those two UTXOs could be on completely different networks, because it doesn't matter to the person receiving them what their relation are to each other. Each UTXO has a history, both behind it and eventually in front of it. And that history is completely isolated from any adjacent history of other UTXOs even if they're coming from the same person, with the same account. And wow, these are really good answers. I don't even need to tell you what the positives and negatives are about UTXOs and accounts, but I will continue
well,
anyway.
I actually, oh, okay. So
Sure.
you're going to go into, I was actually going to ask, it seems like there's there's a lot of advantages and positives for UTXOs. What are the disadvantages? But that's what you're about to go into.
Yeah, of course. Yes, there are positives and negatives to both, like you mentioned, Karen. So we could talk about the bad side. We've talked a lot about the positive side. Maybe we'll touch on some of the other positives if there are other things to mention there. And so one of the bads of your UTXO model when you're using them in a blockchain distributed ledger setting is that you always have to worry about contention and manage it. So what that means is UTXOs are intended to only ever be used once. Similar to, you go to the store, you spend your $20 bill, you can't spend that $20 bill twice. You will get change back from the store in the form of other UTXOs, potentially, but that one's gone. But what happens in the virtual world is you can take that same UTXO and try to spend it twice. So for example, on a single network, you could try to spend it twice, and the network will have to figure out, of those 2 times you tried to spend it, which of the 2 are which of the 2 are the valid one that should be included as part of the history, and which one should be rejected because it's been spent already. And you can imagine that different participants on the network might see these transactions at slightly different times. It might see one first in one case and the other first in another case. And then you would have, essentially 2 different nodes that disagree about which transaction is valid and which one is an attempt at a double spend that should be thrown out. So I won't go into all the ways that gets handled. It does get handled, but it is something that when you're programming applications and when you're reasoning about them, you do have to consider, how is my network going to handle this? And when I do encounter this, what do I do? Do I have to tell the other party that this UTXO has been spent already? Do I have to wait a while in order to see if this one is valid? There are a variety of ways to deal with it, but it is something to consider. Another bad about the UTXO model is that it requires really learning a new way to reason about and structure your programs. So we've become very used to and accustomed to, within a lot of programming paradigms, of always having access to state, being able to change our state, basically being able to be largely the sole authority over the state of our application. And to a lesser extent, this also affects account models within the blockchain and DLT space. But in UTXOs, it particularly requires lots of new reasoning about how your programs get structured. And I'll actually show that in an example later. And as mentioned before, you often do get larger transaction sizes. This isn't always true. There are ways to navigate around it, but in the very basic general sense, as we're trying to stick to with these models, that is a concern. On the account model side, some of the bads are that they're less amenable to state pruning. So someone had mentioned that earlier, where in UTXOs, once you've used one, you can mostly forget about it. Unless you're a new member to the network, then you need all the old history. But if you've been on the network for a while, you actually don't need that history anymore. You've figured out what the current state is. But with accounts, they all depend on each other in a much more intertwined way. They all modify each other a lot more. So while in accounts you actually still can state prune, you can do it a lot less in general on networks than you can with UTXOs. Another thing here is that account models generally also, and this is kind of getting a bit in the weeds, but they tend to mix kind of account models tend to be intertwined with arbitrary state access. And what that means is within a UTXO, when you spend one or you use one, you can only use that once, and it only depends on the state of itself, basically. It is all of the state that you're concerned about. But when you do this in the account model, it could affect the state of anything else on the network as long as it's a current piece of state on the network. So we'll actually see that too, in that how that can create some opportunities for bugs. You also have reordering bugs like we touched on, and that you would use a nonce to try to alleviate. They're a bit less private because when you take your account, or for example, your debit card, and you use it in the real world, one nice thing is that the bank knows all of your states everywhere you spent money, but the rest of the world doesn't. Within accounts, if you try to do that same thing, people can look at the account it came from and see all the other transactions under it. This is a very common thing. You see this, for example, on a lot of networks like Ethereum. You even see this on Bitcoin a lot, where people reuse the same addresses. But the UTXO model in that case is trying to encourage you not to do that. But in general, that makes these things less private because people can go on and actually see these transactions. And then in the private space, you do have a variety of other methods, you know, such as channels and other things called channels that actually help to keep this privacy. But again, we're trying to think about account models in a very general sense. So in general, they're less private, but there are ways to work around it, as with most of these negatives. And sorry, did somebody have a question? I know I can talk a lot, especially about UTXOs and account models. Okay, I guess not. Also, account models tend to be single-threaded. There are a variety of optimizations that I personally am not in tune enough or knowledgeable enough on to explain, but generally, when you're making state updates with account models, and they come with the arbitrary state access, which they often do, then you can only have single-threaded operations. So if I'm doing a transaction and you're doing a transaction, and yours goes and happens first, then my transaction cannot happen until your transaction has resolved. Basically, there's a whole lock on all the state out there, even if our two transactions don't interact. That mainly applies to when there's arbitrary state access within account models, but I have yet to actually see an account model that doesn't really allow for generally arbitrary state access. And let's see.
So yeah, there is a question from HT. They're asking if I hold $100 in a bank, and if a merchant puts a hold up for $100, can another merchant claim it? How does banks handle double spending today?
I'm not sure how banks do it internally, but I'd imagine that no, you wouldn't be able to double spend it. So that I'm not sure on. Banks definitely have their own ways of managing double spends, but there are also, I know there are a lot of reconciliation processes that go into managing those types of issues and other related issues. And that's one of the things too, when we think about, you know, why are distributed ledgers good, is that they make these reconciliation issues largely go away, largely become a question of the infrastructure layer rather than the business logic and reasoning layer, and without having to do so much backtracking all the time and having all sorts of safeguards to prevent these types of issues. So in general, I don't know exactly how, but I do know that regardless of the model here, that solving reconciliation and improving it, both of these models can offer benefits over the current systems we have today. And I hope that answers your question. It's at least answered to the best of my abilities. So now what we're going to do is we're going to take a look at a very simple model of each. And after that, we're going to try to break these models in various ways, which is always the most fun of programming, as anybody knows. So for these models, just take a moment to look at them. And if you can tell me basically what's the same and what's different about them, either in the chat or by unmuting your microphone, feel free, because there's some interesting differences, but in terms of their structure. Okay, so Santiago has a really good point here. UTXOs are a lot more compact in terms of their history. I accidentally skipped to my next slide.
HT says that a transaction contains UTXO, so transaction 3 is mapped to UTXO 0B1C.
Yes, that's correct in the example that we have here. So yeah, for each of these, I've specified a UTXO in the UTXO model, which would actually be contained in a transaction, but for this case, let's imagine each transaction has one UTXO. And like HC said, UTXO here is 0B1C from Bob to me, or Bob to you, is the same as transaction 3 in the account model, where Bob's account sends the transaction to you. And Santiago has a really great point here and I'm going to go into this. The nonce history can be traced in UTX. Oh, I'm sorry. Santiago said that the nonce history, I believe you maybe meant to say, can't be traced in UTXOs. So yeah, in UTXOs, there's no nonces. Yeah, okay. But in account models, there are nonces. And what we'll see is that kind of enables a certain bad behavior that I'll talk about on the next slide. So that's great. I'm really happy that everybody can see all of this from the model and really are grasping it, because that's awesome. This is actually my first time giving this presentation, so I'm very happy with that. Anyway, as you can see on the left, we have UTXOs. When they're coming from you and going out to other people, they are not tied to each other. You can see that the arrows here don't touch. And that's actually, I'm trying to represent there visually an actual technical difference, kind of related to what Santiago said. And one of the other things you can see is that within each UTXO, they're kind of not keeping a history of how many transactions, for example, you have sent, or how many transactions, for example, that Carol and Bob have received. There's nothing there in terms of that. On the account model side, you have yourself, and then you have your account. And within your account, transactions are kind of aggregated and related to each other such that they're ordinal. And here we see the nonces. We have transaction 1, 2, and 3. Both of these, by the way, are very oversimplifications of the actual implementations and how they would work, but just for the purposes of demonstration. And then from there, you can get a graph of where this transaction has gone, and it's gone to Carol's account. And what you can see here too is that this transaction here goes back to you, or rather, and thus goes back to your account. So you get a bit more of a transaction history if this thing was disclosed. You could kind of see the same things within UTXOs, but disclosure is generally a lot more minimized within them, and we'll see that in the next slides. So,
and just before
yes.
you move on,
Mhm.
this this structure that you just highlighted here on the two is really what contributes, right, to the somewhat increased privacy of the UTXO model, right? Because doesn't have that aggregation.
Yes, exactly. That's a great point. Because it doesn't have that aggregation. And really, in real life, these things are a lot more complicated. You can get much more privacy out of accounts than what I'm saying here. But UTXOs have a lot more privacy by default that just doesn't need to be worked into them. And account models require additional things to do in order to get some more of that privacy that you would get naturally out of UTXOs. And of course, UTXOs and accounts can actually be used in almost identically the same ways to each other, but we're talking here about the way that they most encourage their users and programmers to actually use them. Because you can take UTXOs and use them in incredibly bad ways that completely destroy your privacy, and people actually do that quite a lot. Whereas on the account side, you can actually take them and use them in ways that actually give you very decent privacy. But same thing there is that people tend to ignore them a lot. And of course, I am talking a lot. And as Karen says, if you have any questions, jump in. It's
question.
Yes.
So based on what you said in this UTXO model, so the point of these arrows, which are not touched each other's, it means that it's more private and they cannot track the transitions. Yeah?
Yep, that's correct.
Mm-hmm. But in account model, they can.
Yes, indirectly you can track some things.
Okay, thanks.
Yeah.
Thanks for asking, Susan.
Yeah, that's a great question. And it actually leads me into my next slide, which is a problem that Susan and Santiago, and I believe a couple other people have been touching on, is that this leads to essentially what we could call side channel attacks, which is a very general form of attack. So we could say the following happens with the model we just looked at. Number one, Carol and Bob are competitors in the space you work in. They're aware of each other and they compete with each other. Number two, Carol's working on your project and under a very strict set of NDAs. You intentionally haven't told Bob that you're working with Carol. You also happen to be working with Bob. And Bob has actually been working with Carol on another project. And Bob in particular is a less than moral person and is really willing to bend the rules of your network to see what data he can pull out to get more quote unquote competitive intelligence on your operations. And so what we can now do is, and this has already been touched on, so I'll just start stepping through it, is we can start talking about what Bob can do or know to carry out these attacks. And I see there's a question, I'll answer that in a moment, but one thing to keep in mind here as we go through this is that this is a very simple example. In the real world, on a real blockchain or distributed ledger, what you're going to actually encounter are thousands upon thousands of transactions between the same parties over and over again. And so if Bob can figure this out with one bit of data, imagine the types of things that Bob could figure out with a variety of data. You can just start figuring out more and more things about the network that you weren't supposed to know. And so HT's asking, will you share info on how we can implement this in Hyperledger Fabric? I mean, UTXO and account model. Yes, so Fabric in and of itself uses an account model, and they also use something called channels, which actually mitigate a lot of these concerns. As I said, this is an example. And then the other way, if you wanted to try your hands at actually using UTXOs, you can try out DAML, which runs on top of Fabric. And that you can go to the link that I have in the bottom left at bit.ly/try DAML. I recommend everybody just go there and check it out. It runs on Fabric networks. It doesn't interact with existing contracts, but it is a very interesting way to program on Fabric networks and gives you a lot of very nice things for free. And we even have, interoperability layers and all sorts of other things we're working on where disparate networks like a Fabric network and a Sawtooth network will eventually be able to talk to each other and have very interesting, bigger networks, as the space expands. And that's basically my pitch on DAML. But yeah, try it out. So what we can do is step through this problem. So we're going to say that Bob goes home, studies your ledger, and figures out some things about it. We're also going to have two parallel universes. We're going to have the UTXO and Account universes. And we're going to also have, well, one thing that Bob knows is that in order for any project to start with your workflow for your business, there has to be a transaction from you to Bob, and there has to be another related transaction from Bob to you that happen around the same time. And so what we're going to first do is we're going to restrict this model to the things that Bob only knows about and remove the other parts of the network. So all these things in purple are going away because Bob can't actually see these in any real life functioning network, hopefully. Andre, I'm not sure if I could answer that question because I don't know about the decentralized identity methods that would be used as identification on Hyperledger Fabric, unfortunately. But if Karen or Martin know, perhaps they could answer, or maybe that's something that we could revisit after the presentation.
Yep. Feel free to keep going. I'll answer it.
Sure. So what Bob does is he starts another project with you, and he goes and gets a transaction from you to him, and then he starts another project with Carol and goes and gets a transaction from Carol to him. And Bob figures, hey, if I could tie these two bits of data together, I can know maybe if Carol has been working with you, because maybe these UTXOs are related, and if they are in any sort of way, there might be some data between them, which would reveal this other transaction that may have happened. Wouldn't reveal necessarily the data about it, but just the fact that it probably exists to some degree of certainty. But Bob quickly finds out that these two UTXOs have no relation to each other. And this is something that people touched on before in the account model. We can go and do the same thing. Bob says, oh, look at this. Last transaction from you to me was transaction 2. And now the transaction from you to me is transaction 4. Where's transaction 3? And this is even more interesting. On the Carol side, oh, Carol's last transaction to me was number 88. And now it's number 90. Where's 89? From there, Bob can deduce that Carol has very possibly, but not certainly, had some sort of business interaction with you. And maybe it is, maybe it isn't. With more and more data, Bob can figure out and learn more and more interesting things. And even with these types of things, you would probably actually see much more than 2 transactions. And with every transaction that Bob can kind of theoretically derive, or actually practically somewhat observe happened, Bob can become more and more sure about what other parts of what's happening on the network that Bob isn't aware of. And so that's a very interesting thing. And of course, if you have any questions, feel free to ask, or if not, we can go into the real life examples with not exactly this type of thing where with disclosure, but other things. Okay, so here we're going to get more specific, and we're going to look at an actual network. And we're going to look at Ethereum first, and then we'll look at it in DAML, just so we can compare networks that both do, DAML's not really a network, but we could compare smart contracts written within both types of these models. Ken asks, can't you trace it from the transaction graph? Is that in reference UTXO model or from the account model? Okay, so on UTXOs and accounts here that I'm showing, while over here, you can see the full transaction graph. What we did is we made sure that Bob wouldn't be able to see the parts of the transaction graph in both account and UTXO models that Bob wasn't supposed to see. So that's why when you're just the person, if on like a public network, yes, you can see the full transaction graph no matter who you are. But on more private networks, you generally can't. And that would be just a very basic part of the implementation for most cases, though not all. And so that's what we're doing here. We're giving both of these models their best shot at staying private before we are able to figure out other things about them. And so I hope that answers your question, but now we'll look at Ethereum specifically. And so you can take a moment to look at this slide. And if you have any questions, feel free to ask. We actually already are fairly close to the end of the hour, and I really do want to get through to all of this. Todd asked a very good question. How does Bob know there's a missing transaction? The answer is Bob doesn't truly. The answer is Bob knows there are missing transactions. Bob doesn't truly know whether they involve you and Carol, for example, in this example, but Bob can take an educated guess. So what you can see over here is Bob had a previous transaction 2 with you and a transaction 88 with Carol. And what happened is Bob did another transaction with you and saw transaction 4. And then Bob did another transaction with Carol and saw transaction 90. And in both cases, Bob knows nonces increment by 1 each and every time. So Bob knows that there's a transaction 3 that Bob isn't aware of. Bob also knows that there's a transaction 89 here between these two that they're not aware of. Yes, and this is based on an assumption, and this is why it's a side channel attack. Because you can't fully derive the true state of the network with just this small bit of data. But when it comes to interactions between different parties on the network, you can start to make better and better assumptions and better guesses about them. That's also why I have the giant question marks about that next to them here. Where this is one way that Bob could predict this. And as far as nonces go, most networks enforce some sort of strictness to their nonces such that they're either simply always increasing or they're always increasing by 1. If they were, and in general, even if your network didn't make the assumption that they always increase by 1, you would find still that a lot of software where people are actually programming this still does that thing where they just increase by 1 because it's the easiest thing to do and it's the easiest way to track. So yeah, there's assumptions we have to make here about how the network works, but I don't think that that's an unfair assumption or an uncommon assumption to make for these cases. But that is a really great question and great point. Is that, we don't know any of this for sure. And yeah, so on the Ethereum side, we have these functions where you can owe a beer and accept a beer once you're owed it. So what happens here is that we have this very simple function, really very extra simplified, where here, the owe beer function goes, and if Alice were to owe Bob a beer, for example, Alice would go ahead and increase her beer proposal. That's over here. So where it would increase to 1, and that represents the current state of the network. And then an event would happen called beer proposed, and this would notify both Alice and Bob as the recipient that this proposal has happened, And then Alice would also have the total beers owned here decremented. And then Bob later can come in and say, okay, I'd like to accept the beer offer, so we can go ahead and increase my beers owed by Alice to 1 + 1. We're going to go ahead and call beer accepted again, such that we both know that this has happened. And then beer proposals for Alice are also going to be decremented by 1. And this beers owed state here is going to change from a 0 to a 1. This is going to change down to 0, and so on. Yeah. So
Anthony, I'm not sure when this question came in, but Subrato asked on YouTube Live, which of the models is more secure for a limited number of transactions?
I would say for any number of transactions, UTXOs default to being more secure than accounts on a general basis.
Right.
Yeah. But you could always take accounts and use them each individually as one UTXO and basically get the same types of privacy that you would otherwise. But that's just not the way that most people program with them. And that's not the way the model encourages it to happen. So what we have here too now, and we can see, is that Ethereum kind of has this mutable state where these values over here can change, and and all these updates happen by new transactions, calling functions that create changes in this state. And the overarching point here is that the specific bug we're going to look at, which is called a reentrancy attack, can occur because you have to think very carefully about each and every possibility in each and every line of code and how it affects the underlying state. And this can actually be a pitfall that affects even very seasoned programmers sometimes, because you can end up with a bug that's very non-obvious. And very interestingly here too, Bob, because Bob needs to be able to because Bob is also, you could actually ignore this. This is actually an error on my slide. Bob doesn't necessarily need to know about beer zones, so we could ignore that. Gaurav asked, for multiple concurrent transactions, which model should we choose, which can have high throughput? Both of these models can have high throughput. I would say, though, that when it comes to concurrent transactions, like you specified, UTXOs tend to have much higher throughput because you don't need to worry about accounts interacting with multiple accounts at the same time, like you would in an account model. In a UTXO model, you don't have to really worry too much about UTXOs interacting with other unknown parts of the history as much. So in general, UTXOs.
We only have a minute left, Anthony. Yeah. Do you want to wrap it up?
Sure. So I'll kind of skip through this. I actually had a bug in my software up here. If anybody actually catches what I did wrong, then that's really cool. I actually have a bug in how I was going to explain it anyway, so this is perfect. Anyway, what happens here in this model is you get these kinds of multiple concurrent transactions, essentially where a lot of these accept beers are happening before the proposal has been decremented. And as you can see earlier, we had a check on these beer proposals to make sure that they were larger than 0. But we can actually push through transactions where many of those transactions go through before this check ever happens. And so what happens there is Bob essentially manipulates the state to make Alice owe Bob 10 beers instead of just the one Alice had intended. And then that is kind of avoided in a UTXO model where you don't have this tie and this constant state that you're keeping track between the two models. Once a UTXO is used, it's done and gone. And so there you see here that one of these goes through and Alice still owes Bob the beer, but all the other attempts that Bob tried in replaying that trend in re-entering that transaction ended up failing. And so, yeah, that's basically the presentation and how they differ in practice. As always, go check out DAML if you're interested in learning a bit more about the UTXO model at bit.ly/try-DAML. And yeah, if you have any other questions, you can always ask on our forum, and I'd be more than happy to answer. That link actually in the bottom left-hand corner will take you to the forum. And yeah, thank you very much to Karen and Marta for having me and for making this and thank you to everybody who asked all these wonderful questions. You made this a really great session, and I'm actually really happy with how well it went. So thank you all.
Thank you so much, Anthony, and thank you everybody for your participation and your questions. Feel free to reach out to Anthony if you have anything else that you wanted to ask but didn't get a chance to. As I said in the beginning, we have more of these coming. These are our next 2 sessions. And finally, feel free to get involved. I shared some of the chats you can participate in. There were a lot of questions about what's coming out with Fabric. We have this whole chat channel messaging service that you can engage directly with those that are working on these projects and find answers to your questions there. And then finally, thank you so much for joining us. And if you did have any burning questions that you still are lingering, feel free to email us at membership@hyperledger.org, and we'll make sure Anthony gets them. Have a wonderful day. Thank you, everybody.
Thanks, everybody.